Welcome to the how-to for molecules and molecular formulas. So when we think about different compounds, one of the things that we have to think about first is that only the noble gas elements, group 8A, are going to be found in nature as isolated atoms, Most of the elements we find are found in some kind of form, which we call the molecular form. And the molecular form just means that we have two or more atoms that are bound together. So most of the time when we talk about these two or more atoms that are bound together, we describe them using what we call a chemical formula. And so a chemical formula could be something as simple as O2. O2 just means that we have two atoms of oxygen that are combined together to make up a compound. So this is really one of the simplest types of molecules we could talk about. So we have something like H2, hydrogen gas. And in this case, we have two hydrogen atoms that came together to make one molecule of hydrogen gas. We could also look at something like O2, which is one molecule of oxygen gas, O2. But we could also have what we call molecular compounds, where we have more than one type of atom. So something like water, where we know the formula, chemical formula is H2O, which means that we have an oxygen and two hydrogens attached to it. That is one molecule of water. Or hydrogen peroxide, H2O2. We have two molecules of O2 and two molecules of H2, and they're all combined together. This makes up a molecule, or a molecular compound. We have more complex ones where we talk about carbon monoxide or carbon dioxide, methane, and ethylene. But all of these are types of molecular compounds. Most molecular compounds really only contain nonmetals. So there's another group of molecules which are composed of only two atoms, and we've talked about these just a second ago with both oxygen gas and hydrogen gas. These are what we call diatomic molecules. They're molecules composed of only two atoms, and in this case, they have the exact same atoms. Well, there are 7 common diatomic molecules, and you need to memorize these. And in this case, we could talk about hydrogen gas, nitrogen gas, fluorine gas. We have O2, I2, Cl2, and Br2. And I think the easiest way to remember this is that you have no fear of ice cold beer. This is probably the easiest way to remember it because in that case we have the hydrogens, the nitrogens, the fluorines, oxygen, iodine, chlorine, and bromine. So these are the different molecules and molecular compounds. And one of the other important facts that you have to note is that in these compounds, we really talk about the number of atoms. So here we have O2. And here we have one molecule of O2, which means that we have two oxygen atoms combined together to make up one molecule. The number in front of this chemical formula tells us how many molecules we have. So if we put a 2 there, that really means that we have 2 molecules of this O2 molecule. Lastly, we have what we call molecular formulas, empirical formulas, and structural formulas. A molecular formula is the chemical formula that indicates the exact number of atoms in a molecule. So here we have CH4, which means that we have 1 carbon and 4 hydrogens. We could think about this with water, because with water, we have H2O. We could also think of hydrogen peroxides, H2O2. These are the molecular formulas for these compounds. But we also have what we call the empirical formula. And the empirical formula is really just a ratio of the atoms in each molecule. So for H2O, the smallest relative number of atoms in each type of molecule is still 2 hydrogens and 1 oxygen. But for hydrogen peroxide, you really have 1 hydrogen for every 1 oxygen. And so here we're talking about the empirical formulas. Lastly, we have the structural formulas, which is really how those are composed. So for water, we would have an oxygen bound to 2 hydrogen atoms. For H2O2, we could have these 2 oxygen atoms that are bound to one another, and then ultimately bound to hydrogens as well. This would be H2O2. This concludes the how-to video on molecules and molecular formulas.